Hi folks, this is part 2 of this question. I'm using a new software that only gives me 10 minutes for free at a time, so I'm going to start again. So I just want to recap where we were at. Okay, we were able to determine more or less the shape of this function, and what we noticed was that these different branches seem to be approaching 0 towards the right and seem to be getting further away from 0 towards the left. And it seemed to be that these minimum values on the positive branches and these maximum values on the negative branches seem to follow along the numerator's graph. Okay, and the reason why that's happening is on this positive branch, whatever the values are for the numerator function, okay, we're always dividing by, in this case here, cos x, remember, lies between 1 and -1. So when they're on the positive side, I'm dividing these numbers by numbers smaller than 1, making them bigger. But when I divide exactly by 1, I'm right on the function. And it's a similar argument on the negative side. Okay, here I'm taking these values from the numerator and I'm dividing them by numbers that are between -1 and 0. So it's making them more negative. Okay, and where is the, so making them more negative, whereas at this point here, when cos x is equal to -1, it's going to be whatever the y value is from the original function in the numerator, just divided by -1, it's just going to flip it over to the negative side. All right, so I want to close this for a second and let's actually look at, there's part 1 loading, and let's look here at Desmos, and we see that we sort of have this sort of shape that we found before. So take a look at all these sections here. Notice how they're getting closer and closer to 0, okay? And on this side here, they're getting closer and closer to 0 and further away from 0 on the other side, okay? So let's zoom out. Okay, let's zoom out, and now I think you're going to start seeing, oops, sorry about that, you're going to start seeing a very interesting pattern. You see how they start going away from 0 much more quickly. Now, I would say that that's not too surprising because we know that in the numerator, we have an exponential function, okay, which changes very quickly. So what I'm going to do here, just to really indicate this, is I'm going to, there's my graph, and I'm going to graph the numerator, okay? And we sort of see that we have the same behavior that we anticipated having, that these minimums all occur along this edge that is the numerator function. And on the negative side, they seem to be following, hey, look at this, the negative of that function, okay? So this numerator function is providing a boundary on the bottom for the positive parts and a boundary at the top for the negative parts. Okay, now I chose to do part C for a reason, because I want to save something like part A as a bit of a surprise, because that's going to be one of the examples we look at next time. All right, we're going to see how this can be very much applicable to one of the scenarios we've already talked about. All right, so just to recap what we did here. Okay, number 1 is I just started trying to determine as many characteristics of the function as I could based on these numerators and denominators. So I was able to determine the domain, I was able to figure out where the asymptotes were going to be, and I was able to figure out that there were no x-intercepts. From there, I graphed both functions to then try to start reasoning out the shape of the graph based on the behaviors of the numerators and denominators. And essentially, that's what you have to do. So we never talked really about end behavior, and we sort of see that there isn't really an end behavior, because while, it comes down at some point, okay, it starts to get close to 0, it then goes back up to infinity. Then it goes back towards to 0, back down to infinity. So we see that there's this oscillating behavior, not really much to say in terms of end behavior. Okay, so that's all I'll say about this one for now. That's it.